Never mind.
Okay. We're going to take a look at what's, degrees. We know how degrees work. That's really not that exciting. We're also going to talk about radian measurement. Radian measurement is just another way that you can describe or measure angles. For instance, you'll see today a 45-degree angle is the same as what we call pi over 4 radians. Just another way to do it. So how to describe angles, we're going to draw some angles today. The drawing skills, it's not so bad on this stuff. I'm going to show you how to switch back and forth between degrees and radians to degrees. Super easy, little fraction work. And you probably, from geometry, that is nothing different. Complements and supplements. Sound familiar? I feel like I'm teaching geometry today, which is fabulous. Okay, so first, most important step of this chapter is you have to be good at drawing angles today, because they're going to lead into right triangles at some point. Today we just want to talk about drawing. How do you draw the angle? So, of course, when we draw an angle, the vertex is always on the origin, so that's super easy. Our initial side is always on the positive x-axis, so I'm going to fill in over here positive. Now, from there, the other ray, the other side of your angle, can rotate in different directions. It can rotate, of course, counterclockwise, up. It can rotate clockwise or down. It just depends on if you have a positive versus a negative angle. We're going to draw this good stuff today. So the terminal side rotates counterclockwise, and I really feel like I need to get a longer blank here for positive, counterclockwise. I don't know if I'm going to make it. I am not. Whew, definitely needed a longer blank there. My bad. Okay, and then the terminal side rotates clockwise or down for negative. So the positive and negative is just going to affect your direction of your rotation. Negatives rotate down. We all start at this green, mine's green, initial side, and then positive angles rotate up or counterclockwise. Now, of course, I know you know, there are 360 degrees in a full circle, of course. We have 4 quadrants, so 360 divided by 4, of course, 90. 90 plus 90 is 180, 180 plus 90, 270, 270 plus 90, full circle 360. All right, let's talk about this crazy radian stuff. Throwback to geometry, my friends. So 1 radian, it says, is the measure of the central angle theta. The subtends, intercepts, and arc S equal in length to the radius of the circle. That sounds like a foreign language up there. Okay, let's relate it to geometry, something that you know. What is the formula, this is going to be good, for circumference of a circle? That was quick, I like it, 2 pi r. Now, all of our circles, and notice I used the computer-generated ones over there, not my hand-drawn ones. Notice your radius is 1. We are always going to be on a radius of 1, or what we call the unit circle. So I'm just going to pop a 1 in there for r, which, really, we don't need the 1, 2 pi. So 1 complete revolution around the circle is 2 pi. So that is the equivalent to 360 degrees. So 2 pi radians is 360 degrees. So we are going to talk about how to graph angles, draw out angles in radians today. Just another way to measure it. We know a full circle is 360 degrees. We also know going around the circle is the circumference for the radius. Okay, if a point starts at 1, 0, moves counterclockwise all the way around, it's pretty much what I just rambled on about. A full circle, of course, is 2 pi. Your circumference of the circle, 2 pi, radius 1, who needs the times 1. Now, we're going to take a look at, though, of course, we need to label these a little more in detail, how you can move, of course, halfway around the circle or quarter around the circle. So if you're going to, of course, move halfway around the circle, you always start vertex initial. You would be rotating up or counterclockwise. Your half circle there is pi, 180 degrees. We all know a half circle is 180 degrees, which is pi radian. So one thing I want to get a little more detailed on these pictures, because you're going to have to do it today, is labeling these axes. So I'm like, okay, well, we know we start at 0. We know what half circle is pi from this picture. Let's get the other axes. So to scale it, of course, your full circle's 2 pi, and we have our four quadrants. And I'm going to reduce that. So really what you're doing is you're scaling the axes, the quadrants, by half. I just put the 1/2 pi. 0 plus a half, half. Half plus another half, there's my dramatic 1. 1 plus another half, 1.5. I'm just going to write it in proper because it takes up less room. You can put 1.5, I don't care. And then your full circle would get you back to 2 pi. So I always label all of the axes to start with. I mean, eventually, clearly, we're going to get it, and we won't need to be so dramatic with our labeling. But you can see here, too, here is just the picture. They're showing you 90 degrees, which I already labeled over there was our pi over 2. Pi, 3 pi over 2, full circle 2 pi. Now, one thing I'm going to put on here just to make your life easier, because I know it's coming at us, these, of course, are all the pictures. They're assuming right now we're rotating everything positive angles counterclockwise. In the middle, I'm just going to draw a little picture just to show us labeling if we want to rotate negative clockwise. So I'm just going to sneak one in the middle here. So your starting point, of course, still here at 0. We don't need me to draw the circle. Nobody needs to see that. But of course, we're going to be rotating clockwise or down. So you're going to be subtracting a half a pi, subtracting. So 0 minus a half. Minus a half. Negative a half, minus a half, negative 1. Do you need the 1? No, but I just drama. You know, I like the drama. Minus another half. 1.5. I just write it in proper. It takes up less room. That's my only logic on that. Minus another half gets you back to that full circle. So the negative just affects which direction you are rotating. Okay? That's all the negative does. So some brand new stuff. You've never done degrees, radians. This is something new. So that's why I do kind of talk about the radians a little bit more at the beginning. The degree part's easy. Nobody messes up the degrees. Okay, so determine the quadrant in which the terminal side of the angle lies. And I'm just picking up a copy of the homework here. So I'm going to pause. So this is kind of like numbers 1, 2, and 3 on the homework, kids. 1, 2, and 3, just for the record. Okay, so let's, of course, determine the quadrant in which it lies. So I'm just going to use one graph for all of them. We don't need to draw 4 graphs. That's obnoxious. I'm just going to kind of make mine in the middle. Now, quadrants. First thing I'm going to do is label my 4 quadrants. Of course, quadrant 1, top right. Quadrant 2, 3, 4. Now, I see all 4 of my angles in this problem. We will do negatives, but all 4 of these are positive for right now. So I'm going to start labeling according to my positive graph. And they're all in radians. So add a half pi, add a half pi, half plus a half, add another half in the full circle. So of course our full circle, we're rotating counterclockwise. Man, that was a pretty good circle for me. I'm kind of proud of that one. It's the little things, kids. Okay, so what I need from you, your final answers for these are which quadrants, which numbers are these angles going to lie in. So you're going to be a little good with fractions. 1/5 is 1/5 between 0 and a half, between a half and 1. Clearly not between 1 and 1.5 or 1.5 and 2. So my question for you is which quadrant is 1/5 pi in? It's between 0 and 1/5 is between 0 and a half. You've got to be good with fractions. 1/5 between 0 and a half, 0.2, 0.5, if that helps. So that would be in quadrant 1. And we are going to start drawing the actual angles next. Okay, I think the 7/5 is a little tricky because it's improper. Sometimes I think it's easier to think of that mixed number style. Okay, got it. So if I were to mark out 1 and 2/5 more. So 1 and 2/5 is in between 1 and 1.5. So that angle would end up being in quadrant 3. Now, don't think I had a stroke and I forgot the pi's on these. I didn't. Remember, pi is just a decimal, 3.14. So I know, just because I've done it forever and a day, 3.14 over 2 is about 1.57. That's not 3.5, and not it. Still going, still going. Pi, I know that one. We got it. Not it, not it. 3 pi over 2, if you punch that in your calculator, the actual pi key, 3 pi divided by 2, it's about 4.7. Okay, okay, looking good, looking good. So 3.5 is going to be in between 3.14 and 4.7, so quadrant 3. And you should be able to answer this one. Where's 2.25 going to end up in? Which quadrant? Quadrant 2. I see you holding up a 2. So, dramatic. So the only thing that's really going to change here, it's just a little more obnoxious, you have to actually draw the angles. Besides just telling me which quadrant it is in, we're actually going to draw the picture for each one of these. Oh, and a negative. Good. Okay, good. All right. So as always, again to start with, we're going to do our dramatic labeling. Positive. Got it. 1 pi. I'm not putting the 1 anymore. 1.5, our full circle. Okay. So to draw your angles, vertex on the origin always. Our initial sides on that positive x-axis. Now 5/4, good at fractions, got to be good at fractions a little bit, 1.25. So right now I can tell you which quadrant that's going to be in, because it's between 1 and 1.5. How am I going to get a protractor out and measure? I mean, let's get serious here. I'm at 1/2, 1, 1.25, kind of in the middle there. I don't know if that's exactly in the middle. I'm going to roll with it. Now, I don't care if you do this next piece. I just like to label from here to here. We covered 5/4 pi. Because eventually we're going to be making some right triangles, etc. All right, let's get crazy and do a negative one, finally. Get some negatives in here. Now remember, the negative just affects the direction you rotate. You're going to rotate down or clockwise. So I'm going to label 0, but now we're subtracting 1/2 pi. Subtract another 1/2. Subtract another 1/2. And then our full circle. Now, same thing for all 4 of these pictures, vertex on the origin. I got to be good with my fractions. So I'm going to rotate clockwise or down. So I'm like, okay, negative 2/3. Is that between 0 and negative 1/2? Nope. Is it between negative 1/2 and negative 1? Sure is. It's going to be kind of close to negative 1. I'm going to ballpark it. Looks good to me. And I just like to label because that's how I roll. Let me kind of move this up a little bit so I feel like I'm way at the bottom here so you can see this. 7 pi is the fun one because what's a full circle in radians? How many pi? 2. So we have to go, we got to kind of hot lap the circle a couple times. Okay, all right. I'm not scared. We're going to do it. So positive, positive. So I'm labeling like the green. 0, pi over 2, another 1/2. We know it, a full circle. Okay, so get it labeled. Same starting. Now, here comes the drawing. So, I'm going to have to make how many complete circles? 3 will put you at 6 pi, and then we're going to go some more. Here's how you draw it. I love drawing this. Let me draw it, and I'll give you a second to draw it. So, of course, you're rotating counterclockwise up. Here we go. I'm starting here. So, there's 2 pi, 4 pi, 6 pi, still going, 6.5, 7. I know, that little spirally thing. Now, I find that really obnoxious to draw. I think we all agree that that's super obnoxious. Notice my 7 pi, my 3 full circles plus a half circle, my 3.5 circles, you end up at the same place as pi. Isn't it easier to just draw the 1 pi and end up in the same place? It is. And we're going to do that eventually when we start talking about coterminal angles. Angles where you land in the same final destination, but you take a different route to get there. Coming at you in a bit. All right, let's finish this. Negative 3. Now again, I didn't forget the pi. That's, pi is just a number. Negative, so I'm going to subtract 1/2 pi and we're rotating clockwise or down. my negative 3 pi over 2, and my full circle. As always, vertex on the origin, initial side. Now, decimals, I'm not going to get crazy and label them all, because isn't negative 3 going to be close to negative 3.14? I'm going to be pretty dang close to that, okay? That's pretty close. I'm going to roll with it. Got it. So I'm going to hit pause right now, that's fine, but let's carry on to make sure we get through everything. So like I said, the next thing I want to talk about, I don't want to have to draw 7 pi all the time because it's gross. Notice you landed at the same spot as pi. So those are what we call coterminal angles. Remember, you're going around a circle. I could have said graph negative 1 pi, you end up at the same spot. So as long as you end up in the same location, those are what we call coterminal angles. So if I have a really large angle, like let's say I got to do 1050 degrees. Not doing it, not doing it. What I'm going to do is do a coterminal. I'm going to work smarter, not harder. I'm going to add or subtract 360 here. So two angles that have the same initial, I can spell initial, and terminal sides. You end up in the same spot, basically. So you're going around the circle multiple times, or maybe you're going a different direction, you're rotating negative, whatever. You're getting to the same spot. That's what's called coterminal angles. So, I'm going to show you how to find coterminal angles, okay? Which is the next part of your homework. So you probably can do a little of this as I go. Determine two coterminal angles, one positive, one negative. Okay, so we're in radians. One full circle is how many pi in radians? 2 pi, the circumference. So all I'm going to do, I mean, I would never want to graph this, but I'm going to add 2 pi. I'm going to hot lap the circle. Why would I want to go around an extra time? I don't know, but this is how we're going to do it. Now, you got to be kind of good with fractions here. What is 1/9? This is an easy one. 1/9 plus 2. 2 and 1/9. You are more than welcome to put 2 and 1/9 pi. A lot of times, I don't care, leave it like that, whatever. A lot of times you'll see on the answer keys, they'll put them in proper. So I'm going to make it 19/9. I don't care which form you get it. There's my positive answer. Now I need a negative answer. So this time, I'm going to take my angle, and instead of adding a full circle, instead of rotating counterclockwise or up, I would just rotate clockwise or down. I'm going to subtract a circle. Okay. What's 1/9 minus 2? Now, if you're like, oh man, if you don't like fractions, no judgment, little judgment, do it in your calculator. Do the 1/9 minus 2 part in your calculator and just throw a pi on it. And speaking of your calculator, one of my trig kids just showed me this the other day, and some other math teachers I was showing them too. They've never seen it either. Normally, I harp about the fraction bar. I do like alpha y equals and pull it up. It's not going to work on this version. It's the newer ones that will do it. Let me show you. Let me grab one of these guys. Click this over so you can see it. So if you, come on, maybe I'm going to click it over. So if you, let me blow this up so you can see it. So if I want to do that 1/9 minus 2, if you hit this alpha key and then the key directly to the right of it, it automatically pulls up the fraction bar for you. You don't have to go through any menu. On the newer calculators, not every model will do it. So I can just do my 1/9 minus 2. So I'm going to put for my answer negative 17/9 pi. I got to put the pi back on. Don't forget the pi. There's 17/9. Okay. Or you could make your common denominator and do it in your head. Because again, I just think of 2 pi, because I'm kind of good at fractions, it's 18/9. 1/9 minus 18/9. There you go. Okay. All right, so same thing. First, I'm going to add 2 pi. Now, let's go old school. Common denominator, 2, of course, as I just know, is 6/3. 6/3. 4 plus 6, 10. 10 pi over 3. And then I'm going to subtract 2 pi. So I'm going to minus, I'm not even going to write 2 pi, I'm just going to put it in the common denominator style right now. I'm going to put 6/3. 6/3 too. I'm like, oh, that's easy. 4 minus 6, negative 2/3. So it's just adding revolutions, going around the circle. I'm going to pause for a second. 6, I'm going to go out of order while we're on the coterminals. So now I'm going to add 360. So one of my answers, 396. And then, of course, we're going to subtract 360. And I don't need work for these, of course, on the homework, but I'm just writing the work on your notes here. So punch that in. I'm just going to set that down and get it out of the way here. So negative 324. So if you were to, if I made you draw out 36, 396, negative 324, they're all going to land in the same final destination. That's what we're doing. All right, same deal. Add 360. So that's going to give you 315. And then subtract 360 because I want one positive, one negative. So I'm going to put negative 405. So you probably already have 17 and 18 on the homework. Type it away, my friends. And there is a C to this one. Now, the only reason I gave you C, because I mean, it is still easy adding and subtracting 360, but I was like, oh man, I don't know if I want to really add 360, because is that going to make it a really big number? Yeah, I don't want to do it. Now, it's already over 360, so I'm going to subtract first. Okay, so take 360 off. So type that in quick in your calculator. What's 740 minus 360? 380. Okay, I can roll with 380. There's my positive answer. But if you take 360 off again, take another circle, you're going to have 20. Do you have a, look closely, a positive and a negative answer? You could give me this for your positive also. That's why it says there's many correct answers. You could take either of those, but I need to get to a negative. So just make sure if you have a very large angle that you subtract enough off to get down to a negative. Not that that's that hard, but just it wants a positive. For your positive, you could have given me the 20. You could give me 20 and negative 340. I don't care. Okay. So you should be able to do back to example 4. So I know we're kind of all over because I'm trying to help you with your homework here. Get it together. Now these pretty darn easy. Determine in which quadrant. Well, again, I'm just going to kind of draw the graph in the middle for both. Degrees is always easier. You just told me a full circle. We all know it is 360. What's 360 divided by 4? 90. So we're scaling this by 90. 90 plus 90. 180 plus 90, 270 plus 90. I don't know why I'm going to label the quadrants. I know you know them. We're all geometry pros in here. Okay. All right. Very dramatic picture, which most of you probably could have just pictured it in your head. 121 degrees is going to land in which quadrant? 2. Now, I didn't draw out the negatives, but I think we can handle it. Negative 22 degrees, you're going to rotate clockwise or down, you're going to land in which quadrant? 4, you'd be between 0 and negative 90. So that is, so that's 10 through 12 on the homework. So 10 through 12, you can tell the quadrants. Let's draw the angles in degrees. Degrees is always easier. All right, so 180 degrees, 90, 180, 270, my dramatic labeling, full circle. Okay, don't let the 180 intimidate you. 180, of course, is half the circle. Still, start drawing it the same, meaning vertex on the origin, initial side. We're going to rotate counterclockwise or up, 90, 180. You're going to land right on the axis. This is, I'm going to get fancy here, what we call a quadrantal angle, I just like to say quadrantal, any of the angles on the axes, they give them a fancy name called quadrantal. So 90, 180, 270, all quadrantals. Don't let it scare you, can land on an axis. Okay, now, I don't know about you. I can't say is I want to draw negative 450 because you're going to have to go around the circle more than once. So we're smart, we're going to use our knowledge. I know I could add what to that and end up at the same spot. Yeah, so let's add 360. Work smarter, not harder. What's negative 450 plus 360? Negative 90. Well, that's a piece of cake to draw. Got it. We're going to rotate down clockwise and up right there, negative 90. Okay. You can mark out the 450 if you want to. So that is going to be 13 through 16 on your homework. On the notes here, so we did 6. So we're on this part. So at some points, we're going to ask you for the angles and degrees and radians. We're going to have you switch between the two forms. So to convert, of course, to convert degrees to radians, you multiply by pi over 180. Now, just to explain the why on that, a full circle's 360. A full circle's 2 pi. If you cut them each by 2, 180 is 1 pi. So that's your relationship. That's why they're going to the 1 pi and the 180 on it, just a little easier. And then, of course, you multiply the opposite to do radians to degrees. Okay, little fraction work here. Express the angle in radian measure as a multiple of pi. Now, they do not use a calculator part. If you got to use a calculator to do the fraction reducing, I don't care. They just don't want you using the 3.14 and giving a decimal answer. So I'm in degrees, the red, the top. We're going to multiply by pi over 180. So all I'm going to do in my calculator, now unfortunately this one doesn't do it. Most of you, if you hit that alpha and the key right next to it, I'm going to pull up my fraction bar. I'm going to put in the 315. That's on top, 180's on the bottom. I'm going to let my calculator reduce it. So I have 7/4, and then I'm going to put the pi on. So you can use your calculators to reduce the fraction. We just don't want the pi key in some rando decimal answer. So same thing, pi over 180. Now this time I think we could reduce it in our head because the zeros, the hundreds would cancel out. 6 goes into 12.2, 6 goes into 18.3. Same thing, pi over 180. And I would reduce the negative 144 over 180 in my calculator to get negative 4/5 for it. And then I'm going to show you, because I see you're working on the homework. Hopefully, I'm hoping we can get done. We're crushing it. The opposite. If you're in radians and now you want to go to degrees, you multiply by 180 over pi. You're making the pi's cancel each other out. So then in your calculator, negative 4 times 180, of course. Make sure, this is nitpicky, you put the degree symbol on. Because of course, if you don't have the degree symbol, you're implying you're in radians. Okay? So same thing, same math, 180 over pi. And of course, the pi's cancel out. Now I can do this in my head. 60 goes into itself once, into here 3 times. So I'm left with a negative 15 times 3. Got it. Okay. So that is like, all of this is like your 19 to 23 on your homework. So let me pause for a second. So I'm just filling that in on your notes. Complements add to 90, supplements 180. Now, they might give you the radians, of course, so I'm going to put slash pi over 2 in radians. Half a circle's 1 pi. So I'm just going to put the radians on 2 for you, for the love of math. So fill that in on your note sheet. And I'm pretty proud of us. I think we're going to get all the notes and homework done today. Am I right? So find, if possible, the complement in the supplement. Okay, this is a problem already. I don't like it. I don't like the complement for this, because is your angle already over 90? Yeah, and they don't want a negative answer for this, which would be nice if they told you such a thing. They're just assuming everybody's going to magically know that. If it's over 90, you don't have one. Or if, let's say, you were doing a supplement, if you're over 180, you don't have it. All right, supplement. How much more do you need to get to 180 from 129? Little calculator action. What's 180 minus 129? 51, I heard it. Okay. Now, if you're in radians, they want the answers in radians. You always see me tell you that on test. So I'm not going to convert to degrees and convert back to radians. That is obnoxious. I know complements, 90, radians is pi over 2. So I'm just going to subtract off my angles to see how much more I need. So I'm going to do a little fraction work here. 1/2, 1/6. Either do that in your calculator or make common denominators. I know 1/2 is 3/6. Oh, okay. 3/6 minus 1/6, 2/6, 1/3. So I just took my 90, what we have to add up to, just like here, you did your 180 and subtracted your angle. We'll do the same thing for supplement, but I don't think I have to do as much work. So supplements should add up to 180 or pi in radians. And I'm going to subtract off my angle to see how much more I need. We don't need a calculator for this. What's 1 minus 1/6? 5/6, done. Okay, so that is all the complement over you to the area. And I know you know area formulas here. So I'm just going to fill it in on the notes, so if you want to start doing the area, you can. So the sector, remember from geometry, is a wedge, a piece of the pie, a piece of the circle. So the area of that is 1/2 times the radius squared times your angle. Theta represents your angle. Now before you do this, don't jump ahead of me. Nitpicky, it would be nice if they got specific here. This angle needs to be in radians. So that's why I was like, oh man, I gotta be careful here. Find the area of the sector. All right. Radius squared, radius down there 3, got it. But my angle's in degrees. So, I'm going to convert it into radians. 60 and 180, of course, reduce. It's going to be pi over 3. Okay, so let's do a little math here. Of course, 3 squared is 9. So I'm going to keep it, of course, as exact as possible. So I'm not going to grab my calculator and hit the pi key. I'm just going to try to simplify this fraction stuff. Like 9 over 3. So 3 times 1, 3. So I have 3/2 pi. And we are in meters. So for those of you that